So what we're going to do now is talk about another technology primer, just to give you some background information. This one's perhaps a little bit less important because the web API tools that we're going to be using do a pretty good job of hiding all this stuff away from you. So although we're going to be using JSON and we're going to be seeing JSON when we test operations inside Postman or a browser or whatever it is we choose to do, in real life, in most environments, the serialization and deserialization of this stuff will just happen automatically for you, and you'll just wind up dealing with objects just like you would in other web services environments. But I do think it's useful to have an overview of what JSON's all about. If you haven't come across it before, it's very prevalent now. It's probably the de facto standard for representing structured data on the web these days. You know, XML is still heavily used, clearly, but it's certainly on its way out compared to newer formats like this. So JSON, the abbreviation there stands for JavaScript Object Notation. And essentially, like XML, it's really trying to do a similar thing to XML, but in a more efficient way. So it's a textual format to facilitate representing structured data and interchanging that data between different platforms, different operating systems, different languages, and so on. It was inspired originally by JavaScript object literals back in the early days, and now, as I say, has become pretty much a de facto standard. Even though its name is JavaScript Object Notation, this is nothing specifically to do with JavaScript, that's just kind of where it came from. JavaScript does have the ability to process this kind of data built into it and deal with it through OO mechanisms and so on, but that's not going to impact us in any way. As you can see, JSON uses braces, brackets, colons, and commas to delimit things. As you can see, it's a little bit less verbose than XML, but it's also somewhat less descriptive than XML as well. You know, in my mind, it's not all good news. There's nothing here, for example, that says what kind of object this is. In XML, there would be something that says, by the way, this is a customer. But there's no name of a class or name of an object anywhere. So there's some different things that you've got to get used to. JavaScript is also agnostic about numbers. It pretty much just uses a human-readable format for numbers, so there's no special weird encrypting of hexadecimal values or octal values or anything like that. It's just human-readable numeric formats. And objects in JSON are simple collections of name-value pairs. Okay, so there's very few data types in JSON. There are a few defined data types, but we'll mention what they are. So basically, JSON supports objects, which are simple collections of name-value pairs, and it also supports arrays, which are essentially ordered lists of items. And that can include ordered lists of objects or ordered lists, arrays of simple types. So the basic notation for an object is objects are delimited with the curly braces. So this says this is the start of an object. Within an object, you have a string that is a name of a property, separated by a colon, separated by a value. We'll look at what the formats for various values are. It can optionally be a comma-separated list of name-value pairs, and the end of an object is indicated by the close brace. So there at the bottom is a simple example of an object definition in JSON. We can see it has three properties: employee ID, which is a numeric literal value, first name, which is a string, and last name, which is a string. Okay, fairly simple. But again, notice there's nothing that says this is an employee. We just have name value pairs for the properties. So it's kind of implicitly implied, you know, in the context of whatever it is you're dealing with, you've got to understand that this is an employee or this is an order or whatever. Now, that's not to say you couldn't build your own mechanisms. You could have a convention that there will be a property called type, and its value will be customer or whatever. You could implement that in your own environment. So objects are declared with braces. Arrays of things are declared or delimited by square brackets. So square brackets, value, square brackets, or square brackets, value, comma, value, and so on. So again, very, very simple syntax, and there's an example of an array of strings, red, green, blue. There's an example of an array of numbers, okay? Of course, each one of these values could be an object as well. So it could be square brackets, brace, property value, end brace, comma, brace, property value, and so on. So arrays of simple types, arrays of numbers, strings, and objects. When you're declaring any value of a property or a value in an array, these are the basic data types that are available in JSON. They are basically string, number, object, which is brace delimited, array, which is bracket delimited, containing other things, and then the Boolean values true, false, and null. Those are the only data types that are available and recognized in JSON. Everything gets serialized down to one of those. And everything can be nested in everything else, and so on. JSON string notation. So a string is a sequence of 0 or more Unicode characters wrapped in double quotes, and basically these are the values of things that can be put into a string. So any Unicode character, or these are the special escaped characters that are recognized. So anything preceded with a backslash and a quotation mark. For example, \b is a backspace, \f is a form feed, \n is a new line, and so on, is what that's saying. Or Unicode characters, \u and 4 hexadecimal digits if you're dealing with Unicode data. Okay, so simple definition of strings. Numbers, this one looks really, really complicated, but it's actually not. A number is simply an optional minus sign followed by 0 or digits 1 through 9, followed optionally by a period and more digits, and also the exponent format is valid as well. It's just a number. So bringing all of that together, basically all JSON data is essentially represented by an object, an array, or an array of objects, and there are examples of both of them. Of course, the indentation here and putting this on multiple lines and whatever is just for making it human readable. It's not necessary. It's supported. It's not required. Whether it's just one big string or whether it's got embedded carriage returns and line feeds and so on is kind of irrelevant. So there's typical examples of, this one is an array of objects, very similar to what you might get back from a typical web service call to say, give me a collection of all people in the department, orders for a customer, that kind of thing. In JSON, whitespace may be inserted between any token, so the parsers and things that deal with JSON don't care about whitespace. Obviously, whitespace within quotation marks in strings is relevant, but anywhere else is not. And because of its simplicity, I read this on the Java website, json.org, the syntax of JSON is never expected to change. So the few slides that we've seen are it. You now know everything there is to know about JSON. It's a very simple format, and probably will not change according to the site that documents it. Serialization and deserialization. If you've ever worked in a web services environment before, or an environment where you're transferring data backwards and forwards over a network, you'll probably be familiar with these terms. But the serialization of something is basically taking an object and transforming it into a string so that it can be transmitted over a network, for example. And in the web services environment, data being serialized and deserialized happens all the time, and very often implicitly, depending on what environment you're working in. Certainly in the server environments. In a client environment, it might be something that you'd have to do yourself. It depends, again, on what tooling you're using. So again, the serialization of something is taking something that's an object in your runtime environment and turning it into a string, turning it into either a piece of JSON that represents the object, or a piece of XML that represents the object, or a comma-separated list that represents the object, whatever it happens to be. And we do that because strings are easy to transmit to other places and are easily understood by other environments. If I take a Synergy object that I'm dealing with in my code and expect to send that out to some other client that might be written in goodness knows what, it's not going to understand it. But if I serialize that object to a string and put it in a standard format like JSON and send it out to somewhere else, there's a good chance that that other environment can deserialize that back into one of its native object types and deal with it natively in that environment. So deserialization is the process of taking that serialized string and turning it back into an object again, not necessarily of the same type. I might send something out from my Synergy environment that somebody's consuming from their Objective-C environment in their iPhone application or something like that. Working in .NET as we do, what you will almost certainly do is you'll probably use an open source product called JSON.NET. It comes from a chap who is called James Newton King, or his company is called Newtonsoft. And this really has become a de facto standard across the .NET world. Pretty much everybody uses Newtonsoft JSON to deal with JSON data in the .NET world. I noticed the other day, if you go to the NuGet package manager in Visual Studio, JSON is the top of the list because the default list you get is number of downloads. I think Newtonsoft JSON is at like 55 million or something like that. It's some huge number of downloads. So if you're in the .NET world, this is almost certainly how you're going to deal with it. If you're working in an environment like Web API 2, for example, Microsoft will inject Newtonsoft JSON for you into the package, and they use it too. Yes, it's open source, but when you do a file new Web API project, Newtonsoft JSON's already in there, and their code under the hood is using it, and it's there for you to use as well if you wish. If you're writing a client and you're doing things kind of manually and just issuing HTTP requests, then you can choose to use Newtonsoft JSON to do your serialization and deserialization as needed. And we'll see some examples of that happening right towards the end of the day. It's very, very simple. Here's an example of using it. So in .NET, here we're creating a new person object and giving it some initial values. If you're not familiar with this syntax, it's been around a little while in Synergy now. So data P is new person, and these are just initial values for properties within the person class. And then this is an example of serializing using Newtonsoft JSON. So it provides a class called JSON convert that has a static method called serialize object, and you pass in the object and it returns the JSON string. So it's very, very simple to use. And the opposite is also true. JSON convert.deserialize object is a generic method that accepts a type of person. So you're saying, please deserialize this string to this type of object, and it will read the string, parse the data, and return P as the person object to you. Clearly things could go wrong. You know, if you hand it the wrong piece of JSON and there's invalid stuff in there, you're going to get errors and stuff like that. But assuming you're passing it an appropriate type of data, then it will do the serialization and deserialization for you. Like I say, in the Web API world, when we're implementing a service, we don't really need to worry about this stuff. Web API does it all for us. It's really when you're writing a client that you're more interested in the serialization and deserialization.